Okay, I'm going to go over all the study guide answers and how to get them. So starting with number 1, this is a proof. And as with any proof, you want to start with the given. And the first given is AB is congruent to DE. They've got that there for you in step 1. The second given statement is angle B is congruent to angle E. And they've already got their reason there. That's given also. If you look at the third given statement, that's angle A is congruent to angle D. They have already filled that in for us, but that is also given. So pretty much all the information we need is given. We just need a reason for this last step. Now that we have those things, how do we know the triangles are congruent? Well, if you look at what we have marked up here, we've got angle, side here in the middle, and then another angle. So we got angle, side, angle. 2 pairs of congruent angles with a pair of congruent sides in between. Number 2, most of the work is done for us. We just have to fill in the last reason. So it tells us these 2 sides are congruent, RP and RS. It tells us angle T and angle Q are congruent. And both of those things are listed in the first step as given. The second step tells us that these 2 angles in the middle, angle 1 and angle 2, have to be congruent because they're vertical angles, and we know vertical angles are always equal to each other. And then now, once we have all that stuff marked on the triangles, we can say the 2 triangles, the triangle on the left, the triangle on the right, are congruent by angle, angle, side. We have 2 pairs of angles and then a pair of sides. So we just need a reason for this last step. How do we then know that side RQ, which is this side here on the bottom left, and side RT here on the bottom right, are congruent? We know they're congruent because they are parts of congruent triangles. And they are corresponding parts. They're in the same place on their triangles. So we're going to use CPCTC. Corresponding parts of congruent triangles are congruent. All right, number 3, we did this in class and gets cut off a little bit at the bottom. What they're asking us to do here is to figure out if the 2 triangles they're describing are congruent or have to be congruent based on the information they give us. And so the way I want to draw these is, I'm not going to draw them so they look congruent because, well, you'll see as I do this. So I'm going to start with, we got angle ABC, and I'm going to make that look like this. There's angle ABC, or triangle ABC. Say B is here, C is here. And it tells us that angle A is 35 degrees. All right, so I know that. I'm going to draw my second triangle XYZ. I'm going to try to make these angles fairly close. And I also know that when I draw the third side, side YZ, it's got to be congruent to BC. So I'm going to try to make it look about the same length as BC. And this is pretty decent here. So we've got X, Y, Z. And we know that angle Y is 65 degrees. So that looks pretty close. Angle Z is 80 degrees. And then it tells us that Y, Z, and BC are congruent. And I tried to draw these so that side YZ and side BC would be about the same length, and where the angles were fairly close to accurate. I think angle Z is probably a little bit bigger than 80 degrees, but the angles are pretty close. And what I want to do here is figure out what other stuff do we know because of the information they gave us. And the one thing we can figure out here is angle X. If we work this out, we add the 2 angles together, Y and Z, and we subtract those from 180 because we know all 3 angles have to equal 180. I don't know what I did there, but sorry about that. Here we go. Subtract from 180. We can find that angle X is 35 degrees. So we know angle X is the same as angle A. We know we have 2 sides that are congruent, or a pair of sides that are congruent, CB and YZ. But you can tell that these are two very different looking triangles, and they're not actually congruent. And the answer on number 3 is going to be no, they are not congruent. And I put a different answer on the study guide I uploaded onto Google Classroom. But just something like not enough information. We don't know enough stuff to be able to say that those have to be congruent. We only have one pair of sides and one pair of angles, and we need at least another pair of angles to be able to show that those are congruent. So not enough information. All right, moving on here. Here we go. All right, next page here. Starting with number 4. If two triangles are congruent, fill in the blank. And if two triangles are congruent, that means everything about them has to be the same. They have to have all the same measurements, and that involves the angles, that involves the sides, and that involves the area, the amount of space inside the triangle. And if all the sides line up and are corresponding and are exactly the same and congruent, the perimeter also has to be, because perimeter is just all the sides added together. So on number 4, every answer is correct. On number 5, it tells us about two triangles, and it gives us 3 sets of congruent sides. So JK is congruent to PQ, KL is congruent to QR, LJ is congruent to RP. If you look at the order of the letters, it follows the exact order they appear in the names of the triangles. So JK and PQ go first. And then we have KL and QR. Those are the second and third letters. Then LJ is the third letter and the first letter, which is the same as RP. So everything matches up, and we have 3 pairs of congruent sides. So if we have 3 pairs of congruent sides, all the sides are in the same spot, everything's matching up, we know, yes, they have to be congruent by side, side, side. So side, side, side means we have 3 sets of congruent sides. Then for part B, we said there must be a series of rigid motions. So rigid motions would be translations, reflections, and rotations. Whenever you have 2 congruent shapes, there must be some way to do a set of translations, rotations, reflections that take one shape and get it so it lines up perfectly with the other shape, so that all the sides and angles match up. Number 6, all the ways we can find triangles congruent. Angle, side, angle would work. Side, side, side works. Angle, angle, side. Whenever you have 2 angles in a pair of sides, as long as they're in the right spots and they're matching up, they work. Side, angle, side. 2 sides with an angle in the middle. That always works. Hypotenuse, leg. That only works for right triangles, but if you got a right triangle, it works. The 2 that we never use that would not work are angle, angle, angle. If you don't have a side, then you could get 2 triangles with different sizes. Even if they're the same shape, they'd be different sizes. And side, side, angle. If the sides and angles are not in the right place, you can get 2 triangles that have 2 pairs of congruent sides and a pair of congruent angles that look very different. So those are the 2 you eliminate. The other 5 work. Number 7, it gives us 2 angles on a triangle. It wants us to find the third. So what you're going to do on number 7 is just add these together and subtract them from 180. So I believe the way I wrote it on the one I uploaded to Google Classroom was something like this. That's what you're going to work out. But I'm just going to go over here on the side and add 42.8 to 67.3. And I get 110.1. So I'm going to subtract that now from 180. And I want to get 69.9 degrees. So add the 2 angles you know, subtract them from 180, that will tell you the third angle, 69.9 degrees. All right, next section here, bottom of this second page, find the value of x. We did this one in class. There's a lot of ways you can think through this. Here's how I'm going to do it. I'm looking at the second triangle. I know that because the two triangles have to be congruent, we said they're congruent by angle, side, because we have two pairs of congruent angles, and then we have at least one pair of congruent sides. So that means if this angle at the top is 40, if these triangles are congruent, this angle over here also has to be 40. And on this triangle, I have one angle down here marked as 3x plus 4. If these two angles at the bottom are congruent, the other one also has to be 3x plus 4. So now, just looking at the right, the triangle on the right, it's not a right triangle, the triangle that's on the right, I have 3x plus 4 plus another 3x plus 4 plus the 40 at the top has to equal 180. The angles of the triangle always add up to 180. Now I'm going to combine my like terms. So I get 6x, so 3x plus 3x. Then I'll take 4 plus 4 plus 40. That's going to give me 48. And then I'm just going to solve my equation. I get 6x on the left. I get 132 on the right. I'll divide both sides by 6, and I'll get that x is equal to 22. And that's what it's asking us to find here. It's just asking for the value of x. So x is 22. Number 9, which of the following sets of side lengths could make a triangle? The rule is any two sides you add together have to be greater, or give you a number greater than the length of the third side. And the way you test it is by taking the shortest two lengths. So on A, you'll take the 11 and the 5, you add those together, you get 16. 16 is not bigger than 18, so A does not work. B, your two shortest are the 27 and the 8. Add those together, you get 35. 35 is not bigger than 43, the third side, so B doesn't work. For C, your two shortest are the 14 and the 7. If you add those together, you get 21. 21 is bigger than the third side. It's bigger than 19, so C works. Let's go ahead and just finish this off to test answer choice D. If you take 3.5 and 5.5, you get 9. 9 is not bigger than 9. It's equal to 9, but it's not bigger than 9, and it has to be bigger. So D does not work either. So add together the two shortest sides, the two smallest numbers, and find the one where it's bigger than the third number. Number 10 is related to that. We didn't go over this one in class, but it's same concept as number 9. You want to figure out what range of numbers would work where a number would make a triangle with 42 and 83. So what kind of numbers would work with 42 and 83 to make a triangle? So what you're going to do here is you're going to take the two numbers they give you, you're going to add them. So 42 plus 83, that will give you 125. You're also going to subtract them. So I'm going to take 83 minus 42 and correct my mistake, and I get 41. So I know that to make a triangle with a side of 42 and a side of 83, I need a number that is bigger than 41 and less than 125. So that's how I'm going to write my answer. I'm going to say x is bigger than 41, but less than 125. And I get those numbers by adding the two numbers they give me and by subtracting the two numbers they give me. Let me move this out of the way here. Number 11, which side of the triangle is longest and which is the shortest? And on a lot of triangles, you can just look at it and tell. And this one, it may be kind of obvious. But if it's ever kind of iffy and you're not 100% sure, the rule is the longest side has to be opposite or across from the biggest angle. So the side that is opposite from the 89-degree angle, the biggest angle, is side AC. So AC has to be the longest side of the triangle. Your shortest side is always going to be opposite or across from the smallest angle, which here is the 37. So the side that's across from the smallest angle is BC. So you may get a diagram where it's really easy to tell, but if it's hard to tell, that's the rule. Longest side is across from the largest angle, shortest side across from the smallest angle. All right, I'm going to switch up the color here. Used a lot of orange. Number 12, we want to find the length of side EF, and right now it tells us side EF is x plus 5. We don't know what x is, but we can use the fact that this triangle is an isosceles triangle, and we have two congruent sides to figure out what x is, because we know x plus 5 has to be equal to 2x minus 9. So now we can work this out, and I'm going to subtract the x from both sides. I get 5 equals x minus 9. I'm going to add the 9. And I get 14 equals x. Keep in mind, though, that's not my answer. I got a little more work to do. I've got to plug that back in. So I'm going to take this 14. I want to find EF, so that's x plus 5. So I'm going to plug the 14 in for x, add 5 to it, and I get 19. So the length of side EF is going to be 19. Number 13, I'm going to switch colors again so it's really clear what goes with 12 and what goes with 13. Let's do this magenta color here. We got to find all three missing angles. I would start with angle X, not only because it's first in alphabetical order, but because X is part of a triangle where I already know two angles. I have 28 and 39. So I'm going to add those together. Yeah, I get 67. I will subtract that from 180. And I get 113 degrees. So X is 113 degrees. Now I can use X, which is 113, to find Y. Now, there's a couple ways you could find Y. Y is, if you kind of forget about this other line here, Y is an exterior angle of the triangle on the right. So Y has to be equal to 28 plus 39. So you could do it that way. But the other way to do it is X and Y are a linear pair. They make a straight line here. So they have to add up to 180. So I can take 180. I'll just do that over here. 180 minus X, which is 113. And that's going to tell me Y. And I should get 67. So Y is 67 degrees. But notice that it is the same as what I got when I added 28 and 39. All right, now I know what Y is. It's 67. So now I can find Z by adding together the 64 and the 67 and subtracting those from 180. So I've got two angles in that triangle, and they add up to a 131. So I can take a 180 minus 131. I should get 49 degrees. So Z is 49 degrees. So there you go. That's your answer on number 13. Number 14, let's just keep switching colors here. Okay, number 14, we did go over this in class, and it's kind of a lengthy explanation, but it ends up that the triangles cannot be proven congruent. And the reason is because even though you have what appears to be angle, side, it isn't actually angle, side because your two sides are not in the same spot. So if you look at the triangle on the left, the side that's marked as congruent is touching angle K, which has one arc. If you look at the triangle on the right, the side that's marked as congruent is not touching the angle with one arc. It's not touching angle U. It's touching angle S, which has two arcs. So the sides are not in the right spot. The other way you can think of this is if you tried to move these around and do rotations and reflections, try to line them up with each other, there'd be no way to line them up. Any way you did it, one of the angles or sides would be out of place. All right, number 15, it says solve for x on the pentagon. And what we need to know first is how many degrees are all the angles in a pentagon. So we need our little formula, which is s minus 2 times 180. For a pentagon, s is 5. So we're going to have 5 minus 2 because it has 5 sides times 180. And that is equal to 3 times 180. Or 540. So now we're going to take the 5 angles, we're going to add them up and set them equal to 540. So we have 91 plus 125 plus 92 plus 3x minus 5 plus 4x minus 8 equals 540. And sorry, I kind of ran out of room there. But now we're going to combine our like terms. I'm going to do this over the side, 91, 92, and 125. I'm going to add those 3 numbers together. I get 308. I also have a negative 5 and a negative 8. So I'm going to subtract those. Like subtract the 5. I'm going to have 303. I'll subtract the 8. And I'll get 295. So when you're combining like terms, don't forget the numbers that are part of the 3x minus 5 and the 4x minus 8. So I get 295 plus I have 3x and 4x. So that's going to be 7x equals my total, which is 540. Then I will work this out here over on the side. I'm going to subtract 295 from both sides. And I'm going to get 7x equals 245. When I divide by 7, I get x is 35. So that's the answer there. So figure out what is the total of all the angles on the shape. Then set up an equation where you add all of them together and make them equal to that total. Then it's just a matter of combining like terms and solving it. All right, number 16, we have a mid-segment. So A is a midpoint, B is a midpoint. Connect 2 midpoints, you get a mid-segment. Mid-segment is always half the length of the third side of the triangle. We went over this in class. There's several ways you could go about doing this one. What I'm going to do is I'm going to take the length of AB, 3x minus 1, and I'm going to multiply it by 2, since it's half the length of XC, and make it equal to XZ, which is 34. So then I'm going to work this out. I'll distribute the 2. Get 6x minus 2 equals 34. 6x equals 36. So I figure out that x is 6. This question, though, is not asking for the value of x. It's asking us for the length AB. So I will then take x and plug it back in. So AB is 3x minus 1. So I'm going to replace that x with the 6. I have 3 times 6 minus 1. That's going to give me 17. 18 minus 1 gives me 17. So 17 is the final answer. You may remember there's a much faster way to do that. And if you see that, great. If not, don't worry about it. This way will work for all of these types of problems, and they won't all have shortcuts. So make sure you can do it this way. Number 17 is also a mid-segment problem. And here we're dealing with the angles. We have 2 parallel lines or 2 parallel line segments, DE and AB. And when that happens, we know that the corresponding angles here at ABE and DEC have to be congruent. So we can say that ABE, which is 2x plus 7, has to be equal to DEC, 4x minus 21. Now we can just work out this equation. Add 21 here to both sides. I get 28 equals 2x. Divide by the 2. And x is equal to 14. And once again, that's not the final answer. That's just what x is. I have to plug it back in. So AB is 2x plus 7. I'm going to write that over here. I'm going to plug in 14 where the x was. So I've got 2 times 14 plus 7. And that should give me 28 plus 7, which is 35. So my final answer for angle ABE is going to be 35. It's a 35-degree angle. All right, 18. I've got to find the value of x on this diagram. This is exterior angle theorem. I got this 153 on the outside. I've got these two angles on the other side of the triangle on the inside. And I know if I add those two angles together, x minus 4 plus 2x plus 10, they've got to equal that angle on the outside, the 153. So I'll combine my like terms. When I do that, I get 3x plus 6, because negative 4 and 10 gives me 6. I will subtract my 6. I get 3x equals 147. A little out of room here, but I'll divide by 3. And I find that x equals 49. And that's what I'm trying to solve here. I'm just trying to find the value of x. So I'm done. X is 49. Number 19, find the measure of one angle of a regular decagon. And it tells us a decagon has 10 sides, which is very important to know. So the first thing we have to do, just like on number 15, is use our little formula, s minus 2 times 180, to find the total of all the angles of the decagon. So s here is 10. So we have 10 minus 2 times 180. That's going to be 8. So 8 times 180, which is 1,440. So in a decagon, all 10 angles total add up to 1,440. We want to find the measure of one of these angles, and the thing that helps us here is that it's regular, which means all 10 of them have to be the same. So what we're going to do is take that 1,440 and just divide it by 10, and that will give us 144 degrees. So all 10 angles in that regular decagon have to be 144 degrees. Last question. Number 20, which of these is correct? So we did a couple like this in class. We have two triangles, and they have two pairs of congruent sides. The triangles, though, are not congruent because the third side is different. Triangle ABC has a third side of 8. DEF has a third side of 7. What this problem wants us to do is compare angle A with angle D and say which one's bigger, or are they the same? So what we want to do is look at the opposite sides. And the side opposite angle A is an 8. The side opposite angle D is a 7. Since the other sides of the triangle are congruent, what we can do is say, well, kind of same as when we were just doing this with one triangle, the bigger angle has to be opposite or across from the larger side, the longer side. So since A is across from 8 and D is across from 7, A has to be bigger. So we're going to choose this first answer choice here. The measure of angle A has to be bigger than the measure of angle D. So there you go. I hope that's helpful. I do have all the answers written out on Google Classroom too, if you just want to look at those without the video. But there you go, and good luck on this test.